Good afternoon, everyone. Today I shall be attempting to explain Wien's law to all of you. Now, Wien's law is a simple law that relates the absolute temperature, T, of a black body to the peak wavelength, lambda max. Now, it's important to note that temperature is obviously in Kelvin, and lambda max should obviously be in meters. So the law states that the peak wavelength, lambda max, is inversely proportional to temperature. And the constant of the product of these two quantities, so lambda max multiplied by the absolute temperature, is known as Wien's constant, and it's denoted by a B, and it is equal to 2.9 times 10 to the minus 3 meters Kelvin. So the equation that I've mentioned before, just now, that links them is peak wavelength multiplied by temperature, or absolute temperature of the black body, is equal to Wien's constant. So, let's see this in action, in conjunction with Stefan's law, because they often do come into play together in exam-style questions, for instance. So, let's say that light, which is coming from the sun, has a peak wavelength of 500 Newton meters. And let's use this along with the fact that the sun's radius is, one second, let me just check the actual value. So the sun's radius is 700,000 kilometers. So R is equal to 700,000 kilometers. Let's use these two in conjunction to figure out the energy radiated by the sun per second. Yeah, so we'll be using Stefan's law as well. Right. So first, what do we need to do? We need to figure out the temperature of the sun, the surface temperature of the sun. So that is going to be Wien's constant, so B, or 2.9 times to the minus 3 meters Kelvin, divided by the peak wavelength, so 500 times 10 to the minus 9, because that's 9 meters, and that's going to be equal to 5,800 Kelvin. And now, to figure out how much energy is outputted by the sun every second, we're going to use Stefan's law. So I covered Stefan's law in the last video, and it's right over here. And it's L is equal to 4 pi r squared sigma t to the power of 4. I'll just copy and paste that down here. So yeah, remember to always write out formulas. So we know what the radius of the sun is. It's 700,000 kilometers. So now all we need to do is put that into the formula. So 4 times by pi. I'm just going to type in 3.4 for now, but use the actual value of pi. Multiplied by r squared, so that's 700 million actually, because it was in kilometers, all squared, multiplied by sigma, so that's Stefan's constant, 5.67 times 10 to the minus 8, multiplied by the temperature to the power of 4. So we know the temperature is 5,800. That's to the power of 4. So if we input this into the calculator, so it's 4 pi times 700 all squared, multiplied by Stefan's constant, by temperature to the power of 4, we get 3.95 times 10 to the 26 joules every second. So in terms of power, that's, yeah, it's watts. If you wanted to estimate the power, calculate the power output by the sun. So huge amount of power. But yeah, that's Wien's law, and that's how you use it in conjunction with Stefan's law when you're doing a question. Thank you very much for watching, and good luck with your A-levels.